Metals can vary greatly from one another in terms of their appearance, properties, uses, and reactivity. Gold, as an example, is yellow, relatively hard, and very unreactive. Potassium, on the other hand, is gray, relatively soft, and reacts vigorously with oxygen and water. We can actually organize these metals according to their reactivity. This arrangement is known as the reactivity series. The most reactive metals are at the top, and the least reactive at the bottom. We can use this series to predict whether or not a single displacement reaction will occur. This is often of importance in industry as it can be used to obtain pure forms of valuable metals from their compounds. A single displacement reaction is a reaction whereby one element displaces another within a compound. The key idea here is that a certain element can only displace another in a compound if it is more reactive. Here is an example. When we add a strip of zinc to an aqueous solution of copper 2 sulfate, we can see from the reactivity series that zinc is more reactive than copper and can therefore displace copper in copper 2 sulfate. We can see this happening over time. The bright blue copper 2 sulfate solution gradually turns into colorless zinc sulfate, and copper metal begins to deposit on the zinc strip. Can you predict the products from this single displacement reaction? Pause the lesson and continue when ready. As copper is more reactive than silver, it can displace silver in silver nitrate, producing silver metal and aqueous copper 2 nitrate. If you look closely at the series, you will see that hydrogen and carbon are added for comparison purposes. This is important to help predict whether or not a metal will react with an acid or if it can be extracted from another compound. Magnesium metal will dissolve in hydrochloric acid, releasing hydrogen gas and forming aqueous magnesium chloride. Since platinum is lower than hydrogen on the series, it will be unreactive in hydrochloric acid. This series is also important when it comes to the extraction of metals from their ores. Malachite contains a high percentage of copper 2 carbonate. Heating copper 2 carbonate decomposes it to copper 2 oxide. When you add charcoal, a form of carbon, this enables the extraction of copper metal, as the series tells us that it is more reactive than copper. Can you predict the products of this reaction? Pause the lesson and continue when ready. Here is the answer. In summary, the reactivity series ranks metals according to their reactivity and can be used to predict whether or not a reaction will happen.